I think he's using Starlink and the Earth is moving.
Okay.
Maybe there's a moment I can do that clarification thing from earlier. I don't know.
Go ahead, Rick.
So the distinct difference between this gravitational acceleration and, let's say, if gravity were sideways, would distinctly be the stratification of material or matter itself, because gravity can experience free fall, or something can experience gravity at free fall and not stratify, and it is an accelerative observation. Whereas if I'm accelerating, like, let's say, like in a car, there's going to be sloshing about inside of the frame instead of everything moving as one, which would just be a constant motion, constant velocity. And that's the distinct difference between one or the other. And that's why I know we're not going up. So. I don't know if that helped anybody. I think it's an important detail. Oh, Jeremy and Zanuck are both muted. So there's that. Oh, boy.
No, I forgot about Zanuck. My bad. Dude, I don't know how you don't know which one's moving. If you live on a ball and the radius is not changing. Somebody unmuted Zanuck. All right, nice work, guys. If you live on a ball and the radius isn't changing and you have objects that are accelerating, getting closer to the ground of the ball, obviously the objects are the ones moving. They can't work any other way. Especially if you drop those things antipodal to each other.
All right.
Yeah, if you ask me how whether the distance between the dropped antipodal rocks is getting smaller, yes, it is.
Okay, so do you know so when we drop something here on Earth, do you know which the things are which moving? Is it the ground moving up, or is it the objects moving down?
We've been through
or
this a
combination
million
of both?
times. I'm not playing this game.
It's not a game. I'm asking a PhD physics guy a question about physics, and I'm trying to get a straight answer, and it's like you can't give it to me.
I've told you the question you're asking is meaningless. You can say both are moving. You can say one is moving. You can say the other is moving. It doesn't matter. The only thing that you know for sure is that the distance between the two is getting smaller at an accelerating rate.
Yeah, but you live on a ball and the radius isn't getting bigger. You can't say it's both moving. You can't say it's the ground moving. You have to say it's the object that's moving. Otherwise, the radius would get bigger if you were to do this antipodal.
No,
Obviously,
that's just
you know how a ball works.
not true. That's just not true. I can say that both sides of the Earth are moving. I can and I can say that they're both moving. It's the same velocity, and that the rocks are both moving toward the surface. It doesn't have the surface of the Earth is not. The surface of the Earth does not have zero velocity.
Okay, that's fine. If you say the ground's moving and we drop something antipodal, then the radius would have to get bigger, obviously, because that's how a ball works. If you have antipodal
that
spots,
makes no
if you have
sense.
antipodal spots on a ball,
It makes no
if you
sense.
have antipodal, I know it makes no sense.
If the Earth,
spots on a ball, can you guys hear me?
If the Earth is moving,
you guys can't hear me.
And the ground
yes,
is
John,
not
come on, let's give
moving.
this a chance, man. Come on, one at a time.
I've
Give
given
him a
it
chance, bro. His internet sucks. Please.
Yeah, John just wants to overtalk Jeremy.
No, he doesn't want to. He's just frustrated with the concession Jeremy's trying to get.
Dude, the position is ridiculous to say you're on a ball and the radius isn't changing. and you don't know which is the actual thing that's moving when you drop something antipodal. That's a ridiculous position to hold. Sorry.
Okay, so your position is that the ground where you are isn't moving. Is that your position?
No, the position is if you're on a ball, here's the
Is
position.
your
If you're on
position yes or no? Yes or no? Is the ground
it's
that
not.
you're
No, that's
standing
not.
on moving or not?
That's not. This isn't my position. This
Yes
is
or
an internal
no? Yes or
critique within
no?
your.
Is the
You wouldn't,
ground where you're standing
John.
moving or
Effie.
not? Yes or no?
John, why are you doing this, bro?
I'm doing it to give him a little taste of his own medicine.
My
That's what I
position
thought,
is
but
this.
it's not
I'll
necessary.
answer your.
Come on, man.
I'll answer your question, and then I'm going to continue with this line of reasoning I'm in. My position is the ground's not moving. Okay, there's that. Now, if I
Well,
did have
there
the
we are.
position that was, if I did have the position that I was on a ball, I would not, and with a fixed radius, I would not be able to say the ground's moving up towards the objects, because if you were to do that antipodal, you would have to have a changing radius. That's
Doesn't
my
have to be moving up toward the object.
internal critique of your globe model and not knowing which one. Damn, bro. Am I lagging? Maybe I'm lagging. Sorry.
You are a little bit, man. That's probably it.
All right. Yeah.
Yeah, a grad doesn't have to be moving up. It's just not moving. If you, I mean, I know as a geostationary flat earthist, maybe you do take the position that the Earth really, that the ground that you're standing on isn't moving. That's not true, but I can't shake your belief in that. In my model, the ground ground that I'm standing on doesn't have a velocity. The idea of velocity is meaningless. There's no such
Yes.
thing
And
as absolute velocity.
But it's not moving
in
around the sun.
in your model, you can't have the ground moving up to meet the object. It has to be the object is moving down towards the ground. Otherwise, the radius would get bigger. Do you understand that point or not?
I understand the point you're making. You're just it doesn't make any sense. The only thing we know for sure is that the distance between the two things is getting smaller at an accelerating rate. We don't know the velocity
Okay.
of the ground and we don't know the velocity of the rock because those are meaningless statements.
Okay. So you don't know which one's moving when you drop something. That's what I got out of that. Am I wrong or am I right?
That's what he said. Jeremy, yeah, if you're trying to be like more accurate, you wouldn't use velocity, you would say accelerating for both.
He's the only one who said velocity. I've never
I
used
know,
the word velocity in this.
I didn't catch that. Sorry.
If you want to talk about acceleration, then you should equip both objects with accelerometers because there is such a thing as absolute acceleration. You can measure acceleration, as I said in the chat. Your gut is an accelerometer. It feels happy when it's being supported from below. When it isn't being supported from below, you wake up in a sweat because you know you're falling. It's an accelerometer. It tells you what your acceleration is. Now, it doesn't have a
All right.
readout like a real accelerometer does, but you can put an accelerometer on the ground and it will tell you that you're accelerating upward at 9.8 meters per second squared. Make of that what you will. I can tell you what that means in general relativity. Put that same accelerometer on the rock, and it will tell you that the rock is not accelerating. Make of that what you will. I can tell you what it means in general relativity.
Okay. John, let me ask you this. We're in the lab. We have a ball. Okay. You with me? We're in the lab. We got a ball. We accelerate two objects towards the surface of the ball, right?
So you're just going to have a ball, and then you're going to take two objects
Are
and
you
you're
with
going
me
to
so far?
push on them so that they accelerate toward the ball.
Yeah, they're going to accelerate towards the ball.
Okay.
Yep.
All right.
Okay. Now we can see the ball. We can see the radius isn't getting bigger. We can measure it, whatever you want to do. The radius of the ball is not getting bigger. Do we know 100% that the objects are the things that are accelerating, and it's not the ground, and it's not the surface of the ball moving up to meet the objects?
Well, I can certainly tell you that I would say that the accelerometers on the two things that you're pushing would tell you that they are accelerating and that the ball isn't.
No, there's no accelerometers. There was no accelerometers. Maybe you missed the scenario. We just have two little balls and a big ball. The radiuses of none of the balls change, and there are no accelerometers. You're just measuring this. You have calipers, whatever, on the big ball, and we're gonna shoot two little balls towards them, antipodal. Do you know which two of the balls are moving? Do you know if it's the ground moving up to meet the balls, or if it's the little balls moving towards the big ball?
No, I don't, because there's no meaning to motion. Motion is not absolute. Now, if you want to talk about acceleration, we can talk about acceleration.
So you're telling me even though you know that they are getting closer together, the ground of the big ball and the little balls, they are getting closer together, and you know that the radius of the big ball is not changing. You're telling me we're moving in that scenario. Wow.
Are you doing this
Wow.
experiment in a plane, or are you doing it on the ground, or are you doing it in a train, or in the backseat of a car? Where are
We're
you
in the
doing this
lab. We're
experiment?
in the lab, dude. We're in the
Okay.
lab. I told you we're in the lab.
Okay.
You don't know which
And
balls. You don't know if it's the ground
w-
moving or the balls
would
moving. That's the whole.
would your answer to this
If you don't know,
experiment,
you don't know. It's fine.
if we did this experiment in a plane, do you think your answer would be different?
If you do this experiment anywhere in a plane, on a train, anywhere, you do this experiment, and we can measure the radius of the ball, and we can see that the little balls are getting closer to the surface of the big ball. Doesn't matter where you do this. I will know which ones are moving. I will know that it's not the ground moving up to meet the balls because the
You're
radius isn't changing. It's obvious.
you're really
It's
in the matrix,
measurable.
but
It's measurable.
you were in the matrix for a lot of that, but I think you said that it wouldn't make any difference.
Let me repeat it, please.
I think you said it
Let
wouldn't
me
make any
repeat it.
difference.
John,
Okay.
John, let me repeat it, please. If you do this experiment, can you hear me now?
Yep.
If you do this experiment anywhere and I can measure the radius of the big ball and you shoot two little balls towards it and the radius of the big ball is not changing,
Wait a minute.
I will.
Wait a minute. Hold on. Before you were pushing two balls toward it, are you just shooting two balls toward it?
You can push them, pluck them, do whatever you want to do to the
No,
balls. I
I
don't
want to
care.
know if the balls are just moving at constant velocity or if they're accelerating. Are you pushing on them, or or did you just give them a shove and then let them go?
Pick one. It doesn't matter for this scenario. It's irrelevant.
Okay, then let's
Pick one.
just shoot them and let them move at constant velocity.
Whatever you want to do. We should use acceleration because it would be analogous, but
Well,
it's
you
irrelevant for this
choose. It's
scenario.
your example. Take
It
what you
doesn't.
like.
You can,
I can deal with it in any event.
yes, so can I. So it doesn't matter which one it is. It's irrelevant for this scenario. We have two balls moving antipodal towards the big ball. And I can measure the radius of the big ball. And if that radius doesn't change and the little balls are getting closer to the surface of the ball, I will know 100% that it is not the surface of the big ball moving towards the little balls, that it's the little balls moving towards the big ball. It doesn't matter if you do this on a plane, a train, an automobile, in the lab, in Xanax mom's basement, wherever you want to do it.
Okay, well, that's not the way I see it. I could imagine that if you did this in a plane, what I would see is one surface of the ball. I would see both surfaces of the ball moving at the speed of the plane. I would see one ball moving a little faster than the plane and coming toward the ball, and one ball moving a little slower than the plane so that the big ball comes toward it. But I guess you don't see it that way.
No, are we in the plane measuring this?
I don't know where you are. I mean, my point
It
is
doesn't
that
matter where you measure it from.
it
Yo, you know
does
what? It
matter
doesn't matter.
where you
It doesn't
measure
matter
it
where you
from.
measure it from because
It
you'll be able to measure the radius of the ball and you'll know that it's not the ball moving up. It's the objects moving closer to the ball because the radius isn't getting bigger, dude. How do you not
no,
get this? You're a physicist.
that's just not true. It's
You're a
reference
PhD
frame
physicist. How do you
dependent.
not know
Yeah.
this?
John, can I
It's re-
explain this to Jeremy quickly?
yeah, please try. I
All
don't
right.
think you can,
No,
but
no, he
I'd be
will. He
happy
will.
if you'd try.
He will. All right. John, Jeremy, you have two little balls opposite to each other from a big ball. They're both accelerating towards the big ball at 50 miles an hour.
Okay.
If you're
That's a
standing on one of
velocity.
the
That's not an acceleration.
yeah,
That's a
yeah, yeah,
velocity, but we'll go with it.
velocity. But just so we know, I want to pick something that's fixed.
That's fine. It's fine.
If you're standing on the little ball, what that little ball is gonna see is that the big ball is moving towards it at 50 miles an hour,
Hold on.
and
Hold
the
on. 1
little
second.
ball is moving at 100 miles an hour.
Okay, but 1 second though. We're measuring this whole time this is happening. We're measuring the radius of the big ball, right?
Measuring the radius. What I thought you were talking
The
about.
big ball. The big ball has a radius, and we
Yeah.
know the radius of the big ball is not changing. We're measuring it the whole time. You with me?
Yeah.
Okay, so now if you move constant velocity, accelerate, if you move two balls toward antipodal towards the big ball, and we're measuring the radius the whole time and it's never changing. The big ball's radius never changes.
Yeah.
Neither do the little balls. Their radius doesn't change either. Is there a question in your mind on if the surface of the ball is moving towards the little balls,
No, the surface
or if
doesn't
it's
go.
the little balls? You would know that the little balls are moving towards the big ball, right? 100%.
No, not really. If you're an ant and you're standing on one of the little balls, you're seeing
We're
things
not an
differently.
ant. We're not an ant. We're measuring the radius of the big ball, and we know that it's not getting bigger.
Yeah, but in my scenario, nothing changes. No radius change.
That's not my scenario, though. That's not my scenario. That totally disproves not knowing what's moving when you're on a ball with a not changing radius.
I mean, I have to give it to John. You're not getting it.
Yeah, let me have
How
one
am I not
second,
getting
please.
it?
Jeremy, they are choosing not to go along with your scenario and creating their own scenario over top of yours.
How do you
Thank
guys
you.
not get this? How do you guys not get this? There's a ball. There's three balls. They don't change radius. None of
Yeah.
them changes the radius value. The little balls get closer to the surface of the big ball. Do you know which one's moving or not?
Nope.
It's antipodal.
It depends which one is the fixed reference frame. It could the little one.
Your
one of the little
reference
ones
frame.
could be fixed.
Yo, it doesn't matter what your reference frame is. You know the big ball's not getting bigger because you're measuring the radius.
It's not getting bigger, but it's moving towards the little ball.
It can't move towards the little ball because the radius would have to change because this is happening antipodal.
Jeremy,
you
said
do you
before.
understand it? Wow, man, this is
Jeremy,
I feel
you said
embarrassed for you guys.
you said before that it didn't matter that you could do this experiment on the plane. Is the big ball not moving when it's in the plane?
Obviously, if it's in a plane and the plane's flying, then the big ball is moving. However, when it comes to the little balls and the big balls and them getting closer together, we know that the big ball is not expanding, meaning the ground's not going up towards the little balls because the radius isn't changing. That's what I'm telling you. It doesn't matter where you do this, as long as you know the radius isn't changing, you know the little balls are the ones moving because it's antipodal.
You just said that the big ball is moving.
I know when we're talking about in relation to the things getting closer to the big ball, is it the surface of the big ball moving up, or is it the little balls moving towards the big ball? If it's moving in a plane, it's irrelevant. It doesn't even matter for this scenario.
You just said that if the big ball is in the plane, the big ball is moving. Therefore, the surfaces of the big ball
is moving,
are moving.
John. Stop it.
Everything's moving together. Everything's
moving.
Hold on.
Yeah, I think
Yeah, I'm sorry, Jeremy. They're just choosing not to listen to your example. They're
It's pretty bad.
completely
I know, but
ignoring it.
I know, Rob. I know. It's frustrating for me too, Rob. How do you think I feel? If you have a ball and the radius does not change, and there's two balls antipodal getting closer to the surface of the big ball, 100%, you know the little balls are moving because the radius isn't changing, and you know 100% it's not the ground of the big ball moving towards the little balls. If you think it could be that way, why don't you give me a scenario on how that could happen without the radius changing?
Okay, let me give you a scenario. Let's suppose that you're on a skateboard moving 1 mile per hour, and you put a big ball, you firmly attach a big ball to that skateboard, and then you put two little balls on it, one at the back that you shoot toward the big ball at 2 miles per hour relative to the earth, and the other one you just set on the skateboard so that it's motionless with respect to the earth. Now, that little motionless ball will approach the big ball at 1 mile per hour because the big ball is moving toward it relative to the earth while it stands
Hold on, man.
still
Hold on. I'm lost on
relative
this
to the
scenario.
earth. You
John,
put a
I'm lost
big
on your
ball
scenario. Hold on.
you glue a big ball to a skateboard and you
In the
move
middle.
and you make the skateboard on the middle, and the
Okay.
skateboard moves at 1 mile per hour to the
Okay.
north, let's say. Okay.
Okay.
Now you put a little ball on the back of the skateboard and you cause it to move at 2 miles per hour north relative to the ground, so that it's moving at 1 mile per hour relative to the skateboard and the ball to the north. The big ball and the skateboard are moving 1 mile per hour to the north relative to Earth. The little ball on the back is moving 2 miles per hour to the north relative to the Earth, and therefore is moving 1 mile per hour toward the ball relative to the ball, which is itself moving at 1 mile per hour to the north relative to the Earth.
You lost me, John. You lost me, dude. Sorry, man. Can we just stick to my
Okay.
scenario of the three
No,
balls?
mine is way simpler than yours if you can't follow it. Because I guarantee you, I understand your scenario. I've just taken a concrete example and I haven't even talked about the second little ball yet. I've just got one ball glued to the middle of a skateboard that is moving at 1 mile per hour north relative to the earth. And
Hold
then
on.
I
The big ball and the
roll.
little ball. Hold on. The big ball and the little ball are both glued to the skateboard.
No, the big ball is glued to the skateboard, and it and the skateboard are moving 1 mile per hour to the north.
Okay, so we just have a skateboard with a big ball glued in the middle.
Yes.
Okay, now the skateboard's moving in some direction. Fine. Now, what are the two balls? We have two balls antipodal, right?
Well, but let's just start with one, then we'll deal with the other. One of those little balls I put on the back of the skateboard, and I shoot it toward the big ball at 2 miles per hour relative to the ground, which means that it'll be traveling at 1 mile per hour relative to the skateboard to the
Okay.
north.
Okay. All right. Cool.
Okay. Now we put a little ball on the front of the skateboard, but in this case, I just set it there so that it's not moving at all relative to the
Okay. Cool.
earth. Now the big ball on the skateboard will be moving toward it at 1 mile per hour.
But the one ball
Right?
is not the other ball. Hold on. The other ball that's antipodal is just sitting on the skateboard, not moving.
I just
Or
set
it's
it
moving
on the
with the
skate.
skateboard.
I set it on the skateboard and I make sure that it remains. In other words, the point is, I don't know if I have to shoot it or not. It's probably a good idea to kind of be on the skateboard and shoot it at 1 mile per hour south relative to the skateboard, which will make it motionless with respect to the earth.
Okay. In this scenario, are both of the balls getting closer to the surface of the ball and an
Yes.
antipodal?
Yes, at
Okay.
1 mile per hour.
The radius of the big ball is not changing.
That's right.
Right. I can guarantee
That's right.
100% that, yeah, and that's where I can guarantee you 100% that it is not the surface of the ball moving towards the objects, because that's impossible. The radius would have to change. Obviously, it's the other balls moving towards it.
Okay, then.
Or is that the scenario your globe model's
Well,
in?
what if no,
Where
what
one
if
ball's where when I drop something, hold on, is that the scenario your globe's in, where when I drop something one side of the Earth, it's the Earth moving into it, but the other side, it's not? Like, I don't even understand this skateboard analogy, but go ahead, Riggs.
well, what if one ball just has more mass and a denser core to make up for the difference in size? This
Well,
is what they do.
What's that? What difference is that going to make?
Well, I'm just saying, like, there could be other variables for why you could explain away one attraction or another attraction or something like that.
I didn't think we were talking about attraction. I thought we were just talking about balls on a skateboard moving. I mean, yes, there is some
Honestly,
gravitational effect, but it's pretty minimal. I would say negligible.
I just, you know what? I just kept hearing like balls, and I just kept hearing like the balls on the skateboard go round and round, round, and I just, maybe what I said has nothing to do with what you're talking about. I guess I couldn't follow anymore. It was obnoxious. No offense.
No, I was just Jeremy wanted to talk about little balls. I don't know if it was in an attempt to get rid of the gravitational thing or not, but I was just going where he wanted to go.
Just hard to listen to.
Well, I
I may have
agree
missed
with
something.
that. It's an insanely stupid conversation. But if it helps
Yeah,
anybody, I'm
because
happy to have
we
it.
know on the globe, that the ground is not expanding up, because the radius would have to change if you drop something antipodal. It is a stupid conversation.
To be fair, he came up with an experiment. Well, not even an experiment. He came up with a scenario where you could have two balls reaching the Earth's surface at different rates and not have the Earth's radius changing.
In his scenario,
in his scenario with the skateboard. Real quick. Last thing. So the ball that's going north, that's behind the bigger ball that's glued to the skateboard, is actually the one moving towards the Earth, or the bigger ball that's antipodal. And then hold on, the other ball that's on the other side that's moving south isn't moving at all.
I don't know, man.
The skateboard's moving towards it, right? That's what he said. So he's got a scenario where you do have what looks like to be two balls reaching the Earth's surface in this hypothetical scenario, but one's actually moving towards the Earth. The other one's not moving at all. The Earth's moving towards it. But that's a specific scenario, dude. And it's only hypothetical.
That is in no way analogous. Hold on a second, real quick.
Okay, all right.
That is in no way analogous to what they say is happening on Earth. And also, we can still tell 100% that it's one of the balls has to be moving, and it's not the ground moving up.
No, I would just say that I don't, even though I set it up specifically to make it look like that ball on the front, quote, wasn't moving, unquote, I wouldn't maintain that it wasn't moving. It's just not moving relative to the Earth. That's the only thing it's not moving with respect to.
No, I understand.
Okay, but when we drop something antipodal though on Earth, and you're set in the scenario and the model you guys have set up, it's just accelerating down. They're both accelerating down at the same rate. You can't say the one object standing, like, is this in any way analogous to the globe model, the skateboard scenario you set up?
It was your scenario. I was just fleshing it out.
No, you made the skateboards. I made a scenario that's analogous to Earth. You made a scenario that is in no way.
Well, no, because your scenario didn't have gravity, I don't think. It was just balls with little balls moving toward the big ball. That's exactly what my scenario was.
No, my scenario was analogous to Earth. Your scenario was not analogous to the globe model. Your scenario was not analogous to the globe model, because that's not how the globe model works, where when you drop something on one side, it's just standing still and the Earth moves into it, and the other one's actually the thing moving. That's not how your globe works.
Well, I don't. You wanted to have one big ball. You said the ball could be on a plane, it could be in a car, could be anywhere, and then two little balls approaching it. If you were standing in the plane, that's what you would see. But of course, if you're not standing in the plane, you'd see something else. And my scenario was just intended to really highlight the fact that the thing you're talking about, what you decide is going on, depends on your reference frame. It's a matter of, can I say it? Perspective.
I
Yeah.
disagree with
Well,
that, though. And I think
hold
about that.
on.
Hold on. Real quick, Jeremy.
Even in your scenario, even in your skateboard scenario, you're next, Lion. Even in your skateboard scenario, we knew that the ground wasn't moving towards any of the balls. We knew for a fact that was not happening in your scenario. Can you agree to that?
The ground. What do you mean by the ground?
We
You
knew
mean
in
the
your
earth?
scenario, in your scenario, we knew that the surface of the big ball was not moving, was not the thing that was moving towards the little balls.
Well, I set it up specifically so that you would see that the surface of the big ball is the thing that's moving toward the ball, the little ball in front that is, quote, not moving, unquote.
Yeah, but this scenario you set up, if you're saying that's how it is on Earth, that debunks relativity.
No, in fact, what I'm talking about here is exactly relativity, that your description of a process depends on the reference frame that you use to describe it.
Okay, so just before Lion goes, in conclusion, you don't know what's moving when we drop something on Earth, if it's the ground moving up or the ball or the object moving down, right?
I'm
Just in
not
conclusion,
playing that game.
it's not a game. I'm just asking you a straight up physics question about what's happening on Earth. Go
From
ahead,
the
Lion.
Earth reference frame, the little ball is moving towards the Earth. I think
So
that's what he
yeah,
wants to
so
hear.
Einstein said that it's impossible to tell whether the Earth is moving or the sun is moving. Right? There's no experiment that you can set up on Earth. I don't have the quote on me. I'm driving, but somebody can source that and post it if you want. If you don't believe me, John or Jeremy, but I don't necessarily believe Einstein. Like, I know there's experiments that have been done, right, that prove that the Earth is not moving. Right? So like, there has to be an absolute reference frame, and I know you guys say that there isn't. That they're equivalent, right? Like, whether you're the guy falling to the Earth or you're the Earth itself, how do you tell which one's moving? You guys say it's impossible. It doesn't matter. They're the same.
Yeah,
Jeremy's
there's
saying
no.
no, it's not. It's not impossible to tell that there's an absolute frame. Go ahead.
Well, that's right. I mean, that's what all physicists thought in the 1800s, right? But the failure to find, the point is that if there were an absolute reference frame, then we could use that fact to find out how fast we are moving. But there is no way to determine how fast you're moving. There's no, like an accelerometer. And let's be clear what an accelerometer is. An accelerometer is a completely self-contained device. It doesn't
John,
send out beacons. It doesn't do anything. It just tells you how fast it's accelerating. There's
John,
no such thing for velocity.
John, couldn't you use special relativity and go to the place where time is moving the slowest and figure out couldn't you, wait, how's it work?
Yeah.
Couldn't you
No,
use
if
special
there were,
relativity
that's a
and
good
go to the
point.
place where time's moving the slowest or the fastest? I forget which one it is. And then
Right.
find out, that would tell you when you're not moving at all, right?
Well, that's right. If there were a place where time moved slowest, then we could use that fact to determine how fast we are moving. We could use that fact, but there is no place where time runs slowest.
What do you mean? They say, yeah, what?
Time,
The special
if you
relativity.
hold a clock, so you would hold a clock and say, wow, when this clock runs slowest, that means that I'm at rest. But clocks that you hold in your hand always run at the same rate, 1 second per second.
Maybe you can match them up with another clock and be like, oh shit, I was the one moving.
Whenever you measure, and you have to take careful measurements, you can't just look at a moving clock. When you look at a moving clock, you have to correct for the fact that light takes time to get to you from that clock. But if you correct for that, you will always find that moving clocks run slow.
That's why you put a midway point in between the two clocks, an equal distance point. I don't know. Either way, though, John, obviously, on your globe model, the scenario you set up with the skateboard is not what's happening. It's not analogous.
Jeremy,
That's a nuh-uh, I think. I think that's a big
It's just
nuh-uh.
not analogous because the ball has no in general relativity, space-time's bending, and it has to make the little mass move towards the big mass. Is that not how it works?
Say again, I'm not sure I understood that.
In general relativity, doesn't the little mass have to move towards the big mass?
No, it doesn't have to move toward the big mass. I can shoot it away from the big mass. Are you
Yeah, I
saying
know.
in general relativity, if I take two masses and I release them at rest relative to each other, do they come together? Is that what you're asking?